Okay, firing through them today. Graph transformations 2. Next one up. So we need to consider what happens when we have now a multiplier instead of adding something to our function of x. So I'm going to stay consistent. I'm going to use a nice quadratic that I was using during the first video. And what we're going to do is we're going to take our function of x. And I'll use a nice blue. Actually no, black for consistency. F of x is going to be transformed into a times that function of x. Okay, so slightly different to last time. We've now got a multiplier. Let's see what happens when we do it. So my function of x, I'm going to define as, let's go for a nice blue. Oh, actually it was green our first one originally last time, wasn't it? So let's stay with green. Okay, so our function of x, our original function, is going to be x squared minus 6x minus 7. My new favourite quadratic. Okay, now, so what happens when we multiply it by a factor of a? Well, in this case, I'll call the factor of a 3. Should I use 3 again? Yeah, let's use 3 again. What would happen if I had 3 lots of my function of x? I'm essentially taking that whole function, x squared minus 6x minus 7, and multiplying it by 3. And that's the way to think of it. It's quite nice, it makes a lot of sense. This 3, this a, this 3 is on the outside of the function, so we take our function and multiply it by 3. Let's see what effect that has on the graph then. For which I am again going to just move over here and import those two graphs. Here's what our two graphs would look like. We've got our same original function in green, that's x squared minus 6x minus 7. Now, x squared minus 6x minus 7 is also here, but I'm multiplying it by 3. Let's have a quick look at what's happening in our key points, just like we did before. So I may have to zoom in a little bit for this. Okay, minimum point then. You'll notice that my scaling's changed. I just needed to change the scaling on this so that both graphs would fit on the screen. Right, we've got this point here, which I could label. Let's try and do one of my fancy arrows. That's not a fancy arrow. Which I could label with there it is. Oh no, there it is. Okay. Ah, this isn't how I want it to look. Oh no. Okay. Can I move it round? I should be able to. Oh, there it is, rotated. Cool. Right, there's our minimum point. So what is that value? What is the value of that? That's going to be, my x-coordinate is 1.5. Let's do a nice fraction form because we like fractions. And the y-coordinate is minus 10 minus 11 minus 12 minus 13. Okay. What's this point then down here? I'm going to deal in blue now. And hopefully I'll be a bit slicker with my arrow this time. Oh, let's undo that. Oh, I'm not slicker at all. I need some arrow training. Oh no, now it's moved. Oh no. Okay, let's just leave it like that. And move on. Okay, what's this point then in relation to that one? Well, the x-coordinate's still the same, isn't it? It's 1.5. What's the y-coordinate now? Now it's going to be down to minus 49. Okay, I'm starting to build up a picture of what's happening then. Let's take another point. Another interesting point that we found was where the y-intercept was. Now for this I might need to zoom in. Let's see how far we can go in. Okay. Now, I'm going to draw it this time. It's much easier than my arrow. For my green, I've got this point here, which we know is going to be 0 on the x and minus 7 on the y. Now, let's think about the blue then. And we can just see this cuts the y-intercept, it's just here, and we can read that accurately as 0, and you can all see, obviously, that's minus 21. It's not minus 20, obviously. Right, so what do we got? We had 1.5 minus 13, 1.5 minus 49. We had 0 minus 7, we had 0, 21. So what's happening to my x-coordinates first? Well, nothing. My x-coordinates are staying the same. 1.5, 1.5, 0, 0. What's happening from the original equation, the green, to my blue, my stretched one? The original equation to my blue, my stretched one. Same thing's happening every time. It's being multiplied by 3, which makes a lot of sense in terms of our starting point, what we started with. Let's come out again. So I take my function of x, I multiply whatever value I'm getting by a, or in this case 3, and the result of that is that we've got our y coordinates are being multiplied by 3, and if we're going to describe it, my green function has been stretched out in that y direction, and the scale factor for that is, as we said, the multiplier, which is 3. So for your notes, just to formalise this, to get from f of x to a times the f of x is a vertical stretch of scale factor 3. And that's it. First one done, or sorry, third one done, including the other video. Just one more to go. Okay, you've probably guessed what's coming next. We're going to do the multiplier again, but we're going to transform our function of x. So this is effectively 4. Let's go back and put a 3 in front of this one. Oops, that's moving everything around. Let's put a 3 here. So you've got your 4 rules that you need to know. That's including the first video. Okay. So now what we're doing is we're going to transform our function of x. I've done it again. Our function of x, and now it's going to go to function of ax. Now, hopefully by now we're a little bit more used to this kind of notation, and we can see what's going to happen here is I'm going to multiply all of my x's within my function by this constant a. So let's deal with that in numbers. So if my function of x, and I will go blue again, if my function of x equals my favourite quadratic, x squared minus 6x minus 7, what I'm going to do now to do f of 3x, that's going to become 3x, so I apply that 3, that multiplier of 3 to all of my values of x squared, minus 6 lots of 3x, and minus 7 is going to just stay the same. 3x all squared minus 6 lots of 3x minus 7. Let's jump to the graph, see what actually happens to this. So I'm going to shift us over here once again, and we're going to have a look at what's happening. Okay, let's take a second to digest what's happening here and how it can help us. So, again, just like before, for the sake of consistency, I've got our original green graph, and that's our x squared minus 6x minus 7, and we've got this lovely quadratic that we've seen before. Now, I've multiplied my x's by 3 in the same equation, and I've been left with now this blue graph down here. Now, if you're going to describe the effect of going from the green to the blue, you might say it's squashed in. It's come in from from this point here, now it's all squashed in. It's much narrower. So we can think of it as some kind of squash. But what's happening in terms of our coordinates and in terms of what the stretch is and what that scale factor is? So, first thing I'm going to look at now in order to explore this a little bit more, I'm going to zoom in. So I'm going to look at the roots of the equation. So we've got the roots of our original one, and that's green. So the roots of my green one, this first one here, is 7, and that is obviously 0. Okay, what's the corresponding root going to be then on this one? Here, this blue one here, and I'm going to go from over here and have a look for that root there. Well, it's somewhere greater than 2. I'm actually going to tell you what it is. It's going to be there. That's going to be 2 1/3. Obviously 0. Tell you what might help you here. Another way of writing 2 1/3 as a vulgar fraction would be 7/3. 0. That makes things a little clearer. Okay, let's look at another point. Looks like actually the minimum point is going to give me a bit of space, but also it's coming up with some nice values, so that could be a good suggestion. So let's just move down a touch and look at our minimum points. What have we got? We've got this point here, where my x-coordinate is, and let's count in, what have we got? We're at 1, 2, 3. So that's at 3 minus 16. And what's my minimum point for my blue one that's been squished, as we said? Well, that's actually going to be 1 minus 16. Okay, so two things that we can have a look at and compare. Right, first one then. First thing you notice, what doesn't change? My y-coordinate doesn't change, so it's not going to be a vertical stretch this time. It's going to be horizontal, because my x-coordinate certainly is changing. Changing from 7 to 7/3, and changing from 3 down to 1. Now what you'll probably notice is happening is they're being divided by 3. Your x-coordinate is being divided by 3 to get to 1. My x-coordinate 7 is being divided by 3 to get 2 1/3, or 7/3. So how does that relate to what we're dealing with? Well, we said it is our function times 3x. Function times 3x within that bracket. So the effect is, on the function, we multiply all of our x's by 3, but what's happening is we're seeing all of our x-coordinates over here, all of our x-coordinates are being divided by 3, and so we call this one a vertical stretch. Sorry, a horizontal stretch. Let's go back. Let's just erase that. It's not vertical, it's horizontal, it's in the x-axis, so it's a horizontal stretch. Horizontal stretch of scale factor. We said we're dividing by 3. What we call that in terms of a scale factor then is actually going to be 1/3, or 1/a if we're doing our general case. So, function of x to function of ax, this thing at the top here, is a horizontal stretch of scale factor 1/a. The effect of which being, as we've seen just now, we multiply all of the x coordinates by 1/a, in this case 1/3. So 7 multiplied by 1/3 gives you 7/3. Oops, not my pointer. 7 multiplies by 1/3 to get 7/3. 3 multiplies by 1/3 to get just 1. And obviously my y-coordinates aren't affected. And that is your 4 transformations you're going to need to know. What you're going to have to do now is you're going to have to be able to apply them. Oh, I don't know why I've just gone there. You're going to have to be able to apply them, and you'll have an original graph. You might be given coordinates, so you might have to add on, you might have to multiply whatever your scale factor is in order to complete that. Or you might have to do combinations of these transformations. If you're doing combinations of two of them, just do them one at a time. Build it up, and then hopefully you should get up with your right answer at the end. But we will have a practice of a few of these in class. As long as you've seen the effects and you've got these written down, there is a nice summary of this on the chapter summary. Now we're dealing on chapter 4, I believe now, yep, chapter 4. Your chapter summary is on page 68. So have a look through that. That defines what's happening, and we'll have a little practice when we meet again next time. And that is your graph transformations done.